Okay, this problem has a 16,000 Newton truck, which is traveling at 30 meters per second. So here we have a truck, and it's traveling at, in this direction, at 30 meters per second. And the mass of the truck, or actually not the mass, but the weight of the truck, is equal to 16,000 newtons. And it basically has put its brakes on and is sliding to a stop. So it travels a distance before it gets to a stop. Now when it stops, the velocity is equal to 0 at that point here. Okay? There is a braking force, the force of brakes, which is equal to, let's say, about 8,300 newtons. Okay? That's the braking braking force. The question is, how far will the truck slide before it comes to a stop? So we'd like to find out this delta D. Question mark. Okay? So that's the initial velocity. That's the weight. And so we're not going to solve this problem using dynamics, although we could. We're going to be using energy to solve this problem. So what we're going to do with energy, obviously, we have to use conservation. So we're going to say the initial energy is equal to the final energy. Now what is the initial energy? Well, we're not dealing with any change in height. We're only dealing with velocities. So initially, all we have is Ke, which is the initial kinetic energy. And finally, what else do we have? Well, once this truck is stopped at this location here, then what type of energy does it have? It has nothing. It doesn't have gravitational potential energy, and it doesn't have kinetic energy. So we could write 0 here, but that wouldn't make sense. Something else has to be on the right-hand side here for this to make sense. And what that something is the work lost to friction. Okay? Now it makes sense. So our initial kinetic energy is basically completely burned up by the friction of the brakes. Lost to friction. And let's put brakes here. Okay? So let's work out the equation at this point. Initial kinetic energy is 1/2 mv initial squared, and the work done is equal to the force, the braking force, times the distance which it traveled, which is delta D. And by the way, delta D is what we're trying to find out here. That's what we're looking for. So we know we can solve everything in this equation algebraically for delta D. The only thing we really don't know is m, but we know it indirectly because we have the force of gravity. So let's do that first. What is m? Well, the force of gravity is equal to mg. So therefore m is going to equal the force of gravity divided by g. And we can figure that one out by going 16,000 divided by 9.8, which gives us, let's try this out, 16,000, 9.8 divided by which gives us a 1,632. So the mass of the car is 1,633, say, kilograms. Okay. Next, we can now solve this for this equation algebraically for delta D, and let's do that. I'll just change it slightly because the 2 is in the denominator and so is F brake. So it looks a little cleaner. And now that is going to equal 1,633 kilos times our initial velocity, which was 30 meters per second, squared divided by 2 times our brake, which is 8,300. And that's going to give us times 2 divided by and 8,300 divided by 88.5. So that's our answer. 88.5 meters. That's how far the truck in this case will slide before it comes to a stop. And by the way, just a quick question. How fast is this truck going initially? How fast is 30 meters per second? Well, if you want to do a really quick way of converting that to kilometers per hour, you can just go 30 times 3.6. And that'll give you 108 kilometers per hour. So it's going at highway speeds. Okay? All right. And 88 meters is approximately, less than a football field. That's the end of the problem.